Alright, so this is a video about multiplying and dividing integers with models, okay? And by models, we just mean with like pictorials, okay? Visual representations, just to help solidify that concrete understanding, okay? Okay, so let's talk about what some of this stuff will look like. If I look at my very first word here, okay? It says Mrs. Daphne orders her puppy treats from an online store. Listed below are her options to purchase. Rewrite each option as a math expression using multiplication, then sketch a picture. Perfect. So for 4 boxes of 3 treats, what they're saying is we have 4 boxes and there are 3 treats in each of those boxes. That could be represented as 4 times 3. Okay, we're putting that, anytime you have a number next to a parentheses like that, it is implied or understood that we are multiplying, okay? And that's why I have 4 times 3 written that way. And what I'm going to do is I'm going to visualize that. I'm going to draw 4 boxes. Nothing crazy. I'm not a great artist, okay? But 1, 2, 3, and 4. Awesome. Now, in each of these 4 boxes are 3 treats. Okay, so if we had to figure out how many treats we had in total, we would simply just add it up. 3 plus 3 plus 3 plus 3, which eventually gives us 12 treats, right? Well, what do we call a number when we add it and then 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 add it? So that's actually called repeated addition, okay? Repeated addition is just another way to say multiplication or multiplying, okay? Let's go to our second little box up here. We have 2 boxes of 6 treats each. So we have 2 boxes, and in each of those 2 boxes, we have 6 treats, okay? Now to draw some pictures, I'm gonna draw 2 boxes, and I'm gonna place the number 6 inside of those 2 boxes. So again, 6 plus 6 is the same as 2 times 6, or 6 times 2, and we still get the same product of 12. Now earlier I mentioned that repeated addition is multiplication. Well, if you look right here, it says since multiplication is repeated addition, models can be used to represent integers as well. Remember that an integer is nothing more than a whole number and its opposite. So we have 2 times 4. We can use the same type of words here. We have 2 boxes of 4 treats each. That's cool. Or 2 boxes, sorry. 2 boxes with 4 treats in each box. 4 plus 4 is 8. 2 times 4 gives us an 8. Now, before we get to number 2 and number 3, okay, I'm going to add just a little tiny, well, not a tiny box, but I'm going to add something extra here. I'm going to add a box here. I'm going to drag it all the way to the side. And I'm going to continue that box right here. I'm going to say that this is my key because when we multiply and divide integers, there are very, very specific rules, okay? And we're going to talk about what those rules look like. So, when you multiply a positive times a positive, you get a positive. When you multiply a negative times a negative, you get a positive. When you multiply a positive times a negative, you get a negative, And when you multiply a negative times a positive, you get a negative. Okay, we're going to use that for our next really 3 answers. And that'll also help us answer part A and part B as well, okay? So, let's talk about it. We have an integer that's positive and an integer that is negative, okay? So, according to our key, a positive times a negative should give me something. Let's see. Positive times a positive is a positive. Negative times a negative is a positive. Oh, positive times a negative gives me a negative. So I know that my answer will be negative 8. 2 times 4 is 8. That has a negative value. Let me show you why. If I draw a box with the value of negative 4 in it, and I draw a second box with the value of negative 4 in it, and I combine them or add them, then I have a total of negative 8. We'll do the same thing for 3, okay? Positive times a negative gives me a negative. So I will have a negative answer or product. 2 times 5 is 10, therefore I have negative 10. Well, let's prove it. Let's figure out why. Here's a box. I'm going to place negative 5 in there. Here's another box. I'm going to place another negative 5 in there because we actually have 2 groups of negative 5. When you combine those 2 negative 5s, you end up with negative 10. So our key and our rules so far are all making sense. Now, let's look at something else real quick. Let's see. I'm looking at number 4. If 2 times 4 is 8, and 2 times negative 4 is negative 8, then what do you think negative 2 times negative 4 equals? Well, I'm going to go back to my key. Positive times a positive is a positive. A negative times a negative is a positive. Negative, negative. That means my product will be positive. That means I will have a product of positive 8. Now, as far as patterns that we've noticed or should be noticing, is that the same signs equal positive results. Same signs equals positive. Different signs equal negatives. Okay? Different signs equals negative. Now, part B is pretty interesting because it says, since division is splitting a set into groups, predict how this pattern would apply to division. I'm going to help you guys out here, okay? The same rules apply, okay? The same pattern applies. The same pattern applies. All right, and what do I mean by that? I'm going to put these in parentheses to make it a little bit easier. Positive times positive equals positive. Negative times negative equals positive. And on the side, I'm just going to write same sign, right? The same sign means that it's going to be positive. On the bottom, I'm going to add different signs. Okay, we have a positive times a negative. That's going to equal a negative. And a negative times a positive will also equal a negative. And I'm going to write different signs. Because that's really going to be true, whether you're multiplying or dividing. Now going into the next few things here, okay, I'm going to solve it with y'all, and then we're going to try to visualize it as well, okay? So 9 divided by 3, 3 can fit into 9 3 times. Same sign, so the answer is positive. In this case, it's a division problem, so the quotient is positive. I'm going to represent that as 3 groups of 3, but they're all positive values, which helps me out. For 6, same numbers, but we have different signs. Different signs means negative. So I now have -3. I'll still do 3 groups, but this time they're going to be of negative values. And then for -6 divided by 2, again, different signs means the answer is negative. 6 divided by 2 is -3. Because we only had 2 different groups, I'm only making 2 little boxes like that. All right, let's go to the next page so that we can talk more about it. Next page is going to be this one here. Awesome. Now, they want us to model the following problems with a number line. Excellent. 3 groups of 3, or 3 times 3 is 9. We're going to start at 0 and just jump from 0 to 3, 3 to 6, and from 6 to 9, and I'm going to plot my dot right there. When I look at number 9, I see 2 different signs, which tells me my answer will be negative. -5 is my answer. I'm going to start at 0 and go back 1, 2, 3, 4, 5. Remember that your negative values should be left of the 0. I see 2 different signs here, a positive and a negative. So I know my answer will be negative. My product will be -6. And I'm going to start at my 0 and jump 1, 2 twice in the negative direction, which is left, and plot my dot right there. 2 times 5, again, both positive, so my answer will be positive. That will be a 10, and I will make 2 jumps from 1 to 5 and from 5 to 10, and I will plot my dot right there. Now, here we can use models, but really I'm just going to try to solve, okay? So I know I have different signs. Different signs means negative. 6 times -5 is -30. Different signs means my answer will be negative. 4 times -5 is -20. Same signs, meaning they're both positive. That means my answer will be positive. 6 times 5 is 30. -16 divided by 8. They are different signs, so I know that my answer, my quotient, will be negative. And I can just do 16 divided by 8. 8 can fit inside of 16 twice. 2 times 8 is 16. There are no remainders, therefore my answer is 2. Because we're dividing different signs, it is -2. -2. Okay, going to this one, we have 28 divided by -7. 28, 7. I know 7 can fit into 28 4 times evenly. But we have different signs here. So that means this is not just a 4, it's going to be -4. 6 times 9, both the same sign, so it'll be positive. That is just 54. Now here we have the same signs, negative times a negative. Again, same signs mean positive, so even if they're both negative, your answer will be positive. 11 times 4 gives you 44. And of course we have different signs, a positive divided by a negative, so we'll take that 80 and we'll put that 10 here. How many times can 10 go into 80? 8 times. Because we have a positive and a negative, that means that our quotient will have a negative value, therefore our answer here is negative 8. Looking at this next one, number 20, it says Ashley and her sister. So Ashley and her sister, that's 2 people, okay? They decide to split the cost of dinner, which is $14. How much did each sister pay? So, if the cost was $14 and we split that, which means to divide between Ashley and her sister, as an equation it looks like 14 divided by 2. As solving, it looks like 14 divided by 2. 2 can be multiplied into 14 evenly 7 times. Therefore, each sister spent $7. For number 21, Alejandro sketched a model below. Which expression did Alejandro model? So first we have to figure out how many of these we have. We have 1, 2, 3, 4, 5, 6, 7, 8. And each one is a negative value. So this is equal to negative 8, which is helpful when we start solving our answer choices here. We have different signs. Different signs means the value will be negative, but 4 times 4 is negative, or 4 times negative 4 is negative 16. Negative 16 is not equal to negative 8, therefore we are not going to use A. Same signs. Same signs means that they are going to be positive. Is this positive? So right off the bat, we don't even have to solve it. It's not going to work. It's not. Different signs, positive times a negative, we know will give you a negative. 2 times negative 4 gives me negative 8. That's identical, so far so good. D says negative 4 divided by 2. Different signs, so the answer is going to be negative. But we are dividing. So negative 4 divided by 2 will give you the answer, or quotient rather, of negative 2. Negative 2 is not identical to negative 8, therefore that is not the answer. C is our only answer.